Okay, recording is restarted, Animesh.
Hello everyone, and thanks for being here today on the first day of Kubeflow Dojo. So this is the third session of the day where we are now going to go and talk about the overall Kubeflow end-to-end machine learning platform. If you want to know who is speaking, hopefully you can see me on the video, right? Typically we are not keeping videos on to conserve the bandwidth, right? Because we are sharing as well and with the number of participants. So Kubeflow essentially is an end-to-end machine learning platform, right? So the part of the machine learning lifecycle which is focused on essentially, comes after your ETL part of the lifecycle where you have run, extract, transform, load on your data. You have data ingested, cleaned, and ready to go through the ML lifecycle part of it, right? That's where the majority of the focus is. Now, obviously, there are certain projects as well in Kubeflow which do tend to go into the data part of the lifecycle. We have a project, for example, called Feast for feature engineering, etc. But for the most part, the session and the focus for us for the next 2 days will be around the machine learning lifecycle. So when you start building your models, right? Typically, and that's where, I would say at this point, Jupyter notebooks have become the de facto standard to start creating your models, right? So Kubeflow has its own take called Kubeflow notebooks, which serves Jupyter in a cloud native fashion on top of Kubernetes. Once you have your initial model, you are probably looking at either running, and finding the right set of hyperparameters, right? Or, running distributed training at scale. So there are capabilities for both, and we'll dive a bit into them. So once you have run hyperparameter optimization, run distributed training at scale, you have the models. Typically, there is a validation process, and beyond that, you are now looking at serving your models in production. So there are two projects which are very popular into the Kubeflow community around that. One is KFServing, which is focused around the idea of serverless machine learning inferencing, and second one is Seldon, which is optimized ML on top of Kubernetes. So we will go deeper into the KFServing aspects of it. And definitely there are monitoring tools like TensorBoard, etc., right, which are pre-integrated. For example, if you're running the pipelines, there are monitoring boards around hyperparameter tuning, and the cloud native monitoring boards like Prometheus, Grafana, depending on parts of the Kubeflow you are interacting with, collect and show metrics around them. Now, tying all this end-to-end lifecycle together is a project called Kubeflow Pipelines, right? And there is a variation of it called TensorFlow Extended TFX Pipelines. We'll go into those areas as well. About myself, I work in a group in IBM called CODE, Center for Open Source Data and AI Technologies. I briefly touched upon it in the morning session as well, if you were there. And CODE essentially has a set of dedicated open source developers contributing to end-to-end data and AI lifecycle space. We have a project, some of them which are homegrown, which we put out in the open source, some of them which are in open source, which are strategic to IBM, where we contribute. But the group's goal is essentially be focused on open source, right? At this point, we have approximately 40 plus developers in the CODE group spread across our San Francisco and San Jose offices. But there are projects like Data Asset Exchange or Model Asset Exchange, or our trusted AI projects around explainability, bias detection, adversarial detection, which we had put out in the open source, including a very recent one, which is called Elira, which is an extension on top of Jupyter Lab. But then there are also projects, right, as I mentioned, where we contribute heavily in the community. So TensorFlow, Spark, PyTorch, and Kubeflow definitely fall into that specific area. So I lead IBM's engagement into the Kubeflow community. One of the committers there. One of the major focus areas also, which I do tend to drive within IBM, is our alignment with open source data and AI, with the activities going on within Red Hat. I chair our Trusted AI committee, Linux Foundation AI, and work very closely with that community, with our Trusted AI open source projects in that space. Also, there is an ML Ops SIG, right, which I run as part of the CD Foundation, which is focused on the CI/CD aspects of the machine learning pipelines. And here is our team, the excellent team, right, which is contributing to Kubeflow. Now, more than around approximately, on the last count, we have more than 25 IBMers who have contributed to Kubeflow. Now, some of them, do it on a more dedicated basis. Some of them, have particular areas of interest for a particular time frame where they come and contribute. And then, but these are the members you see here, right, who are also majorly responsible for putting up the dojo. They lead, IBM's contributions into the Kubeflow community. So Christian, Wei Shang, Tommy, Andrew, Kevin, they're part of Code, which is our dedicated team around open source contributions. Jinshi and Fong, they come from our systems and spectrum conductor team. Sean is part of the Watson Toolbox team. So, you probably are interacting with quite a few of them on a day-to-day basis within the Kubeflow community. And because of those excellent contributors, right, IBM is now the second largest contributor, and not now, right, it has been the course for the last 1 year, right, we have consistently been the second largest contributor within the Kubeflow community after Google. And this is, the data which is coming from Stackalytics, right, but also if you look at the CNCF DevStats dashboard, that tells a similar story. But we are not the only contributors, right? I mean, there has been excellent work being done by, a lot of the participating companies like Cisco, Erecto, Amazon, Certain, Bloomberg, contributing heavily to multiple aspects of Kubeflow, either within a particular domain area. And they're all bringing, great set of technologies together and putting up this platform together for the community. As far as we are concerned, we are spreading our contributions across, but there have been, focus areas where we are strategically more inclined towards model serving, model inferencing is one space where, there is a strong interest we have. So we contribute heavily there. Kubeflow pipelines is another area. And in this case, Kubeflow pipelines were checked on, and I will come to it, is where we are doing a lot of contributions. But then, we have been contributing to Katib, Fairing, the general, the Kubeflow control plane, which is also something, which we tend to leverage heavily across the OpenShift ecosystem. So when we look at Kubeflow, right, there are two guiding principles, right, behind this. When you look at the vision and the architecture, one is around, the first-class citizen of Kubernetes, right? Now, what lends itself to that is then, the architectural principles and paradigms which flow into that is most of the Kubeflow components are architected as Kubernetes custom resource and custom resource definitions, right? So totally Kubernetes architecture allows you to extend Kubernetes APIs and provide your own implementation. And what happens is, because of that, is you can use kubectl, right, which is the command line which the majority of the Kubernetes community uses. And it's not, overstating the fact that like majority of the enterprises in the world, for when they're looking at cloud native, they are interacting with Kubernetes in some form or fashion, right? So that lends itself nicely to that. But the second part of that architectural principle is, yes, there is a strong community which works with kubectl and Kubernetes APIs, but this is a platform primarily targeted for data scientists, right? So we make sure that, there is a Python interface to majority of our components. There are Python SDKs which are available, and there is a first-class integration with Jupyter Notebooks to leverage them. right? Because ultimately the consumers of this platform are data scientists. Now the providers are essentially the folks, right, who are standing up these Kubernetes Kubeflow clusters and then maintaining them. So, that part resonates with them. So I think this, you can see the vision was to bring data scientists and MLOps teams together to build that one platform which can serve the needs of both. And it will be heartening to say that, we've been pretty successful at doing that. As I mentioned, the community is growing, and I mentioned, the stellar contributions being done there by the likes of, Erecto, Cisco, Bloomberg, Selden, NVIDIA, and quite a few of them contributing to multiple aspects of Kubeflow. And this is a bit of old statistics, right? But, this has been on the upswing since the project started. The other aspect of it is that Kubeflow is now heavily, being focused towards multi-tenant, multi-user isolation model, where you don't need a Kubeflow install per team or per set of users. You can have, highly distributed install of Kubeflow, which is then, multi-tenant, and you can have isolation based on users and groups, which are then backed by, in a lot of cases, the namespace isolation under the covers. So each of these teams then get their own, instances of the notebooks, or they are able to run their distributed training jobs, serving, etc., in their own dedicated namespaces. Okay, so the build part of machine learning lifecycle is very important, right? So build is where we do the initial development of the model. We do distributed training. We are, selecting our set of hyperparameters. And that's where, also there is a strong focus in Kubeflow. So as I mentioned, for Jupyter, right, which is right now the default standard for a lot of data scientists, Kubeflow has built what is called Kubeflow notebooks. So essentially a custom resource and custom resource definitions to actually instantiate Kubeflow notebooks on top of Kubernetes clusters. And then, what that allows you is, be able to leverage the underlying Kubernetes integration, working with CPUs and GPUs, be able to leverage the underlying persistent volumes, etc. So brings all the underlying capabilities of Kubernetes exposed through this Kubeflow notebooks. And then, this is also integrated with our common services, which is Istio, Dex, etc., right, for authentication authorization. So each of the users get their own dedicated installs of the notebooks right within their namespace. The other thing which we have sort of focused on also is that, we are keeping the base images smaller, and what we have seen is moving away from Jupyter Hub to this, we have seen far fewer crashes, a very nimble and agile, Kubeflow notebooks environment. Right, so this is how the Kubeflow dashboard looks like. When you go there, you can see a list of the pipelines, notebooks, documentation around how to get started. You can go to the notebook server tab. You can select, your namespace in which you are operating. It will show you the notebooks you have. You can essentially then, either launch a new notebook as well. And when you click on that, it takes you through the dashboard where you are able to select the underlying, the infrastructure constructs, because, you want to specify, so you have that level of control, whether you want to run it on a GPU or a CPU, what persistent volume you want to use under the covers, etc. Right, and the other aspect, as I mentioned, was that, you can launch your own Jupyter notebooks after this. So now once you have the initial build part, you have your initial model, right, then you start looking at, the next part of it, right, where you essentially are looking for distributed training or hyperparameter optimization, right? So specifically in the context of distributed training, Kubeflow provides, the first class citizens, TensorFlow, PyTorch, distributed training operators, again, designed as Kubernetes custom resource definitions. And then, if you are not using the native TensorFlow or PyTorch distributed training algorithms, right, there is an operator which is based on Uber's Horoward project, which gives you the capabilities to leverage MPI protocol. And I will talk a bit about that as well. But that's not all, right? I mean, TensorFlow, PyTorch definitely are dominant parts of this ecosystem, but depending on the geography you are in, depending on particular community, there are folks who are using MXNet heavily. There is Chainer, which is very popular in Japan. For example, MXNet obviously has its own strong user base as well, right? So Kubeflow tends to go broad, and there are operators. Right now at this point there are 6 operators which are going typically broad across these frameworks. And if you're wondering why scikit-learn is not there, right, which is very popular in the machine learning community, I think it's by virtue of it, scikit-learn doesn't lend itself to a distributed training mode. And that's, one of the restrictions why we don't have it on the platform. But other than that, all your major machine learning or deep learning frameworks are there. Now, as I mentioned, what is happening under the operators when you actually peel, they're essentially optimizing and ensuring that, the distributed training algorithms which are coming inbuilt with these frameworks. For example, TensorFlow uses a parameter server approach where when you are distributing the training across multiple worker nodes, all the weights and the gradients which are being synced are being sent to a parameter server, and the parameter server is then distributing it to multiple nodes and keeping all of them in sync. Now you can obviously scale the parameter server itself, right? So this is the protocol which TensorFlow uses, right? So that's what is inbuilt into the distributed TensorFlow training operator. Obviously, then ensuring that the right consistent consumption of the GPUs, etc., under the covers. But if you're not using, for example, the native TensorFlow distributed training platform or algorithm, and you want to use something like MPI operator, which gives you an already used algorithm. So essentially, in this case, there is no parameter server, right? So all your worker nodes who are getting, who are performing the training jobs, they're syncing the weights and the gradients amongst themselves using, the already used algorithm. And this is essentially a technique which has been made very popular by Horoward, right? They use MPI protocol under the covers, and that also enables, very strong communication from GPU to GPUs, either within a single machine or spread across multiple machines. Right, so that is functionality which the MPI operator covers, and MPI operators, by virtue of having Horoward under the covers, can support TensorFlow, PyTorch, and other operators as well. So, okay, we talked about distributed training and the algorithms and the different operators, right? I've not gone into detail on each of these operators, right? There is a session tomorrow as well where we will be, doing a deeper dive into them. But one of the steps also, which is very important during the build phase, is hyperparameter optimization, right? So Kubeflow has a project in this space called Katib, which is essentially, excuse me, focused on this particular area, and supports multiple, hyperparameter tuning algorithms: random search, grid search, hyperband, Bayesian optimization. And definitely it also starts extending into neural architecture search. So there are a couple of algorithms which we are plugging in there as well. Now, this is one of the projects which is very popular in the space, where people are looking to find the right optimum set of hyperparameters. So it also has its own dashboard. So you can go to Kubeflow dashboard. When you go to Katib, you can look at either provide a YAML, or you have a form-based approach where you can specify the parameters on which you want to optimize the number of counts or runs you want to run for it to find. And once you have submitted your job, you can actually monitor the progress of it, right? So you can actually go and look that for the parameters which you have asked it to optimize, how is it optimizing around it. It will run number of trial runs based on the count you have specified and try to find the optimum rate, right? So in this case, we are optimizing for loss, right? And we are saying, reduce, we want to reduce the loss based on these hyperparameters. So if you look at it, right, it comes with the metrics based on the batch size and the learning rate, right? And you can look at the more details around it. Again, there is a deeper dive into this tomorrow as well, right? Folks who are interested in this, right, with a much deeper demo into this particular part of Kubeflow. Okay, so you have built your models using Kubeflow notebooks. You have, found the right set of hyperparameters, choosing one of the algorithms which Katib provides, and then you have run distributed training at scale, and you've produced your model, the candidate model, which is ready for production, right? Probably we think our job is done, but for a lot of the production use cases, the real job starts at this point, right? Having a production model serving platform is critically important, right? Because that's where a lot of the cost parameters come in as well, because and most of the models, right, heavy duty models, they are running on expensive GPU resources, right? So you want to constantly make sure that they're not over or underscaled, right? If they're not getting utilized, they are not hogging, the underlying GPU infrastructure on which they are served. You definitely want to have a very solid and robust monitoring stack around it, right? Look at the traces, request traces, etc. And then, given the experimental nature of machine learning, one of the things which you will be doing constantly because your data set has changed, or, you have found a drift in the model, there is an anomaly, or, the model is giving biased results, you will be essentially running this again and again, right? So you are essentially rolling out new versions of the model at much more frequency than you typically do in the application world. And if you're doing that, you want to make sure, the rollout safe. Can you roll back? Can you, incrementally increase traffic on your next version of the rollout, and as you are, ensuring everything is right. Now models are also deployed. You want to make sure, the predictions, can it support multiple protocols, HTTP, gRPC, Kafka, right? And is the data plane standardized? Now, a lot of people miss the importance of this particular point because, if you are deploying model, for example, on, let's say, any of the major cloud providers model machine learning platform, right? You are particularly bound to that, the API set in terms of, calling models for predictions, explainability, etc., right? And ideally, in an ideal world, you would want to move models across, right? So I want to move it from IBM Cloud to Amazon to Google to TensorFlow serving to KFServing to Selden without having to rewrite my client. Right, so that's where the standardization around the data plane API protocol plays a big role, and obviously, I mean the multiple frameworks. Right, you want to be able to bring all the machine learning and deep learning models and be able to serve them. The other aspect of it is it's not only predictions. Your model should be giving explanation, should allow you to wire up custom pre-processing and post-processing code, right? Because typically models don't only take. I mean, most of the models take, for example, let's say, tensors as inputs and outputs, but what your end user is giving you probably is an image. You're probably giving back as text as an output, right? So having that capability to plug them in and selectively choose where to run what, right? So you probably want your predictions to run on GPUs, but you want your pre-processors or post-processors to run on CPUs. So a lot of these capabilities are required to serve models in prediction, and that gives you the scale of the problem, right, which needs to be solved in this particular case. Now, the story, I would say around a year and a half ago was that, Selden has started doing, a lot of great pioneering work in this area. We gave a talk at, it was the end of 2018, Tommy and myself, we gave a talk on serverless model inferencing at KubeCon, which was heavily attended, and that was essentially using Knative under the covers. The founder of KFServing, Ellis, he was also there in the talk. Then Google has been doing great work around TensorFlow, TF-serving. So a lot of the work was happening, right? But there was no consistent standardization across this field, right? So what we did somewhere towards the first or second quarter of last year, I would say, we got together and said that, all of us are doing and taking it in our own way, right? And it is time to come together and build something, right, which can hopefully, start becoming the standard which the industry requires around model survey. Right, so that was the genesis of what we call KFServing. So essentially built on the Kubernetes native stack, leveraging Istio and Knative. And our initial focus was, around 80% of the use cases, which is, single models rollout and update, making sure, the founding principle, which is the serverless machine learning inference, the rollouts, the canaries, right, they remain intact across them. And then, providing capabilities to plug in your pre-processors, post-processors, explainability, and then now moving forward into other areas like bias detection, drift detection, etc. So as I mentioned, right, one of the key characteristics of machine learning world, very experimental. You are probably rolling out newer versions of the model much more frequently than you roll out an app. This is not a world where you roll out for 6 months and then you are happy when before the next version comes. So that's where, having the concept of default and Canary becomes very important. And this is one place where we also differed from Knative, where in Knative's construct, if you're aware of it, if you change a revision, then it becomes a new configuration. In this case, we allow multiple revisions before you can finalize, for example, your Canary configuration or your default configuration. And then, you can split traffic across them, right? So if you're rolling out a new revision in your prod environment, you can say, okay, let's just start with 10% of the traffic, make sure everything is good. And then, we can incrementally update the traffic. By virtue of it, right, we are ensuring that we are supporting the major machine learning and deep learning frameworks. So TensorFlow support, for example, is enabled by KFServing. We have NVIDIA's Triton server, renamed at this point to Triton, right, which gives a strong performance for models which need to consume GPUs, right? So that's available for PyTorch, XGBoost, and scikit-learn. We have developed our own custom servers, right? But there is also discussion going on with AWS for them to be able to contribute the latest Torch serve, right, which has been introduced in the PyTorch community very recently. And then Onyx runtime, which was contributed by Microsoft to serve Onyx-based models. And we support, different kinds of storage. Any S3 compatible storage is supported. But then, Google Cloud Storage, Azure Blob, persistent volume claims if you're running in on-prem. So essentially, one of the other things which we ensure is a first-class citizen beyond, the Canary aspects of is the serverless aspects, as I mentioned, right? So that's where, we leverage the underlying Knative constructs of, activator and autoscaler heavily. Right, so activator is essentially the component responsible, right, for buffering your request, and autoscaler is the one, right, which is monitoring the metrics on the activator as well as the queue proxy, and then decides when to scale or, when to scale down, right? So essentially, as I mentioned, if you have configured scale to 0, that means if there is no traffic for your configurable period of time, the model scales back to 0, releases your infrastructure, and then, as traffic starts ramping up, the auto scaling starts kicking in, right? This is also request-based scaling, which is much better than, relying on CPU and GPU-based scaling, which can be, very sporadic, and there is no consistent mechanism around that, right? So typically, by virtue of combining these things, you get a strong control over, Canary rollouts, traffic splitting, traffic percentage control, auto scaling, scale to 0. So all these capabilities, get enabled as part of the KFServing. Now, another area where I do want to highlight a bit of focus is Transformer, right, which is responsible for the pre-processing and the post-processing. And as I mentioned, the advantage of having a pluggable transformer is that, you can have pre-processors or post-processors run on CPUs versus your predictor, right, which is doing much of the heavy duty lifting that can run on a GPU, right? The other aspect which we have integrated is payload logging, right? And that enables us to give much more advanced capabilities around model management and monitoring, right? So for example, because the payload logging, which has been implemented using the standardized cloud events protocol, we can do things where we can gather your payload requests and responses. And based on that, right, we can run analysis to figure out, if there is a concept drift, if there is an outlier, is the model giving, or is the model vulnerable to adversarial attacks? And then based on that, right, you can do alerting, right, whether you need to retrain or to take certain action. Right now, all these capabilities, but the data scientist sees a very simple YAML file, right? That if you're using kubectl, right, if you don't want to see YAML file at all, you can use a Python SDK, which KFServing provides. So don't get exposed to YAML at all, right? I know a lot of us don't want to see the YAMLs, but typically, you get all these capabilities behind the scenes around scale to zero GPU or scaling, safe rollouts, etc. So this is a chart which is sort of summarizing a lot of the capabilities which come as part of KFServing, right? So I wouldn't go through them. I mean, the slides are available, and tomorrow we have a deeper dive session, right, where I will dive into quite a bit of these capabilities. There are a lot of more exciting features coming on, right? The one probably where I'm most excited about is model chaining or model graphs, where you can chain multiple models together with the output of one going into the next, right? So that's plus also multi-model serving, so being able to serve multiple models, so not having a one-to-one relationship between Kubernetes custom resource and a model. So multiple models can map to one custom resource, right? So that handles and lends itself very well also to and enhances the scaling features of it, right? And from an IBM perspective, right, we will also be focusing quite a bit on integrating our trusted AI projects around explainability, bias detection and mitigation, adversarial detection into KFServing features. Okay, so we talked about building your models using Kubeflow notebooks, doing distributed training and hyperparameter optimization as part of the build phase, and then deploying your models in production using KFServing, right? So obviously, I mean, there are still pieces which we have probably not covered. There is a lot of custom tasks which you plug in between these things, and in the end, you need something, right, to bring this whole life cycle together, right, which can automate as much as possible your build, train, validate, and deployment lifecycle, going even to the management and monitoring, right? And that's where Kubeflow pipelines comes in. Again, I would say at this point, the most popular project into the Kubeflow community, and aligns with the larger Kubeflow vision, which is built on top of and for Kubernetes, right? Leveraging all the underlying scalability, resiliency, and the core architectural paradigms, but ensuring that it's consumed by data scientists. So by virtue of that, right, there is a Python DSL which has become very popular, to craft your pipelines. You can craft your pipelines using Python, and then but also be able to leverage the underlying Kubernetes constructs. Like in most of the times, if you're running training, for example, on Kubernetes, your data is probably running in a Kubernetes volume, right? So all those config maps, secrets, Kubernetes volumes, containers, they are exposed as a first-class citizen into that Python DSL, right? So data scientists don't need to understand the underlying infrastructure bits there. Now, if you look at it, this is a sample of the Python DSL. In this case, this is running TensorFlow data validation job, running pre-processing, then using distributed training, running TensorFlow, and then running model analysis on part of it, finally deploying it on KFServing. Now, in a sense, this is running the whole end-to-end life cycle, right? Starting from data validation, right? I mean, you can do things like schema generation, etc., as well, and plug it into this. But if you see the powerful nature of this code, right, you probably are seeing around 15 lines of YAML, allowing you to not Python, allowing you to automate the whole end-to-end, the machine learning lifecycle. That's where, Kubeflow really shines. But then, once you have crafted your pipelines, you can upload them on the dashboard. You can bring your custom ROC curves or statistics and graphs, which you need to display as plugins, right? You're going to be creating a lot of these pipelines, right? This will proliferate, again, going back to the machine learning experimental nature, and you can have very solid and robust pipeline versioning here. Artifact tracking is enabled because this is something, again, very important in the context of machine learning, where all your lifecycle pipelines are producing a lot of these artifacts, and you want to be able to go back to those artifacts produced, investigate them, and ensure they are consistent with the mechanisms you have defined. And then also lineage tracking, right, which is very, very important in machine learning, where tomorrow if my deployed model denies someone an admission in the university, and someone claims, okay, on what criteria did it deny, right? And we find out, okay, is the model doing something wrong here, right? Was it not consistent? Then you need to be able to trace back the whole lineage, right? On what data set it was trained on, what were the hyperparameters used, what was the TensorFlow version used, right? So be able to say, okay, where the problem lies, right? So the whole lineage tracking is enabled. This is, high-level view into the Kubeflow architecture. The entry is enabled primarily by Kubeflow Pipeline SDK to compile, upload, and launch. But there is also a dashboard, hugely popular to upload and launch your pipelines and look at the lifecycle as they are running through it. Then you have, the TFX SDK, which is also getting merged. Both KFP and TFX SDK are, on the verge of becoming one, which will, is an entry point. But for now, you can just use the native TFX SDK and launch with Kubeflow pipeline as a backend as well. And then under the covers, right, majority of the CI/CD is by default, done by Argo in the default version. And then, a lot of your metadata is being stored in MLMD, which is model management database to store metadata and characteristics around it. There is a MySQL database as well, but that is more focused on storing data related to the UI constructs of Kubeflow pipeline. All your pipelines, etc., which you upload, they go to an S3 compatible object storage. Right. And now once you have this up and running, right, as I mentioned, they allow you to tie this whole lifecycle in an end-to-end fashion, right? So you're not only able to run, for example, training here. In this case, for example, which you see on the screen is, I'm not using even any of the training operators, given that this is a scikit-learn model. I'm just training it using a custom, wrapped inside a custom Jupyter notebooks, then deploying that model on KFServing, and then we launch post-processing, scoring clients, monitoring clients to ensure that the deployed models, we are able to send requests, etc. Right. Another project, I think, for the community.
Before you proceed, just quickly, there was a question a couple of slides ago about track taxi trip example that shows lineage tracking. Where is it?
I think I will handle the questions maybe towards the.
Okay,
towards
sure. Okay.
The end of the screen.
Go ahead. Yep.
Yeah, thanks. So, so another project, right, which we have launched in the open source community is around, creating notebook-based pipelines. So one of my colleagues, Luciano, is leading this particular project where you can, drag and drop notebooks, connect them into pipelines, and then launch using Kubeflow pipelines as a backend, which is the first supported backend, but definitely there are plans to extend it to support something like Airflow and others as well. So I think what we have established so far is, Kubeflow, by virtue of bringing all these disparate technologies together now, there are few things which I didn't talk about, like, for example, there is also a Spark operator, which is available, into the Kubeflow community, if somebody wants to deploy that, right? But by virtue of bringing all these projects in the machine learning space, right, it tends to provide this whole end-to-end machine learning and AI platform. What are we doing internally, right? There are multiple teams which have adopted or using Kubeflow pipelines to be more particular within IBM, right? But definitely, investigating other parts of Kubeflow. And I wouldn't go into, different parts of the IBM umbrella, right? But something which is, more for external consumers is, which essentially, we have decided to base our Watson AI pipeline story on top of Kubeflow pipelines, right? And that essentially brings together the pipelining aspect of Kubeflow to Watson. That's what we are working towards. Now, that doesn't mean that, this is something bringing in Kubeflow all in, but essentially Watson has a lot of components around training, Watson Studio, Watson Studio Deep Learning as a service, Watson Machine Learning, which is a product on model serving, Watson OpenScale, which is another product which we have around the model management, as we call it, around explainability, drift detection, bias detection, etc. So these pipelines will become, the technology to run that end-to-end life cycle. Plus, there are products which we have around auto AI, data refinery, right? So the goal is to bring all of them together, but tie them through the Kubeflow pipeline layer, right? So as I mentioned, for example, if you look at this one is going through our data refinery, auto AI, Watson machine learning products, and doing the tasks, right? So this is the work which is in progress now, but this is not Kubeflow pipeline as is, right? So one of the goals which Watson gave us was essentially to ensure that, we run this on top of Tekton backend instead of Argo. And the primary reason being that IBM is strategically invested in Tekton. IBM Cloud supports Tekton pipeline. OpenShift pipelines, productization is also based on Tekton, right? So those are I would say, the stronger business reasons. But in general, what we feel is, there is a more composable and reusable architecture as part of Tekton, where the tasks and the task runs, they are independent entities and independent CRDs within the ecosystem, which allow you to run these things individually without tying it to a pipeline, right? So it lends itself to a better composability as well as reusability from that perspective. So when we started this work, right, we divided it into phases. Phase one was essentially, let's start with KFP SDK and compile it. And once we compile it to Tekton, we can run it on Tekton. Phase two was, instead of going to Tekton directly, let's upload that compiled output to Kubeflow pipeline API and engine and run it through that, right? And, not to deep dive into the details, right? But when we started, this required, bringing together multiple teams within IBM, outside of IBM together to get this done, right? But the net result of that is that, we have now delivered the second release of Kubeflow pipeline and Tekton project, which allows you to use the same KFP DSL, right? There's some restrictions, but beyond that, right, majority of the Kubeflow pipelines which you have will run as is. You compile it to Tekton, take it to the same engine, right? So you get the same experience. In this case, this is a simple pipeline which goes through Watson Studio, Watson Machine Learning, Watson OpenScale. But if you see the YAML which is backing it, on the Kubeflow pipeline dashboard is the Tekton YAML, right, which brings the pipeline spec, the task spec, the condition spec all together into one single YAML. So that's, backing this particular DAG. The second thing is, if you are using, logging by default, right? That's the key characteristics of Kubeflow pipeline dashboard, right? So you again give the exact same experience in terms of being able to space the logs. But if you are also using more advanced features like artifact tracking or lineage tracking, that's all now enabled with Kubeflow pipeline and Tekton backend, right? So pretty strong capability. I'm glad to say that, we have now delivered it, and it also enables, even if someone is just natively working in the Tekton community and needs a Pythonic way of defining Tekton pipelines, right, they can just use it within that context. But for the overall Kubeflow community right now, this is available as an option. And one of the typical pipelines which we use to demonstrate, going through Kubeflow components to run hyperparameter search or distributed training is the MNIST pipeline, then serving it through KFServing, right? So that's also, working end to end using the Kubeflow pipeline and Tekton backend. And depending on the time, I will hopefully be able to, go through some quick demos on that side. Okay, the adoption aspects of it, right? So I mentioned, right, and I will talk about it in the context of IBM, right? As I mentioned, right, multiple teams within IBM who are finding value into the Kubeflow pipelines, and they're using it, as well as, we are working on productizing it. But, we have been also working with quite a bit of customers, right? So for example, we worked with Telstra. We gave a talk at Think in terms of building their Kubeflow environment on a mix of x86 and power infrastructure. So, if you're interested in diving into the details of it, you can go to that particular talk. And the future of that particular work is that, we are now going to be moving, the control plane to OpenShift. And then, the rest of the data plane will be running on a mix of x86 and Power. Another customer which we work with, on which we gave a public talk, and it's again, publicly referenceable, is through the Think session, is Yara, which is into the digital farming space. It's a company in Norwegia. By the way, Telstra, if you're not aware, the previous one is the largest telecom provider in Australia. And then, under, I think one of our first adopters within IBM was Watson speech to text. They have been using it to automate quite a bit of the operations behind Kubeflow pipelines, right? Where we are getting a lot of the audio data on our publicly hosted Watson speech to text APIs, converting it to, splitting that audio, converting it to data, then, doing merge, verification, training, analysis. But they are using the Kubeflow pipeline to automate some part of that process by leveraging our underlying core native other eco products within IBM. Okay, so now we talked about Kubeflow, right? One of the other things which I do want to introduce to the community is, something which our Red Hat colleagues have been building, which is called Open Data Hub, right? And one of the terminologies, for example, which Red Hat uses is upstream, midstream, and downstream. And typically, this is terminology which comes from the oil and gas industry, where upstream is essentially the exploratory process, right? Where you're actually trying to find oil on land or in oceans, right? Midstream is when you are actually now producing it, right? We are actually processing it, producing it, and it requires, multiple people to come together. And downstream is the delivery phase, right? Where you're actually in the selling, marketing, delivery phase. Now that's the terminology which is used. And as I mentioned, right, comes natively from the oil and gas industry and goes through their life cycle. So a lot of the Open Data Hub, right, has been focused initially when it came out, right, there has been a stronger focus, I would say, on the data side. They also address, the ML and AI lifecycle, but very strong on, bringing technologies like Superset, Kafka, Airflow, PostgreSQL, MongoDB, all as a first-class citizen, Apache Hive, right, as a first-class citizen on top of OpenShift. And then they, work with the ISVs and the partners to actually amplify that effort, right? So, for example, working with NVIDIA on ensuring, the GPU integration within OpenShift is very huge. Or working with partners like Selden, where Selden is now available in the Red Hat marketplace. So that's how that ecosystem is particularly being leveraged. And if you look at the reference architecture, right, I mean, it goes across the layers which we are familiar with, and then, maps technologies from the OpenShift ecosystem into that, right? A lot of the technologies will come natively, given that this is the OpenShift ecosystem. So a lot of the authentication, single sign-on, etc., get enabled by that, but then, bringing a lot of these open source projects within that space together and mapping it to layers like data in motion, storage, data analysis, AI and ML as well. So, time check, how much time I have?
It's 15 minutes past the hour.
Okay.
So now, you were going to finish at you were going to keep from you were going to finish at 10:45. So you've got another 25 minutes. Yeah.
That's good. That's good. Thanks.
Good.
Okay. So I was talking about the technologies which Open Data Hub has mapped, right? Now, what's the relationship between Open Data Hub and Kubeflow? Right. One of the key things when, around the end of last year, where Open Data Hub started looking at, the Kubeflow and the strong focus on machine learning and AI side, right? And wanted to ensure, that becomes one of the linchpins, right, of Open Data Hub for ML and AI. And then, also offer capabilities to mix these components, right? So you can mix components from Kubeflow, which are very stronger on the ML and AI side, but also bring in things like Kafka, Superset, Hive, right, if you're deploying this. So one of the first things, right, which we did to enable that ecosystem, because a large part of OpenShift ecosystem, works through operators, right? We created an operator and contributed it to the Kubeflow community, right? And it was essentially done to enable that ecosystem, which leverages operators as the core mechanism of deploying workloads on Kubernetes or OpenShift, right? And then Red Hat colleagues came and did an excellent job of taking it forward and ensuring that that becomes also first-class citizen on OpenShift, so you can also deploy Kubeflow as a first-class citizen on top of OpenShift, right? But that operator can be used not only to deploy on these two platforms, right? You can use that operator to deploy the way you are using, if you are using KFServing currently, to deploy in GCP, AWS, Azure, etc., right? So if you're into that ecosystem and if you like the benefits which operators bring, and for some folks, it's not exactly clear. So let me, just highlight one point. With something like KFServing or, CLI tools which you're running on your machine, you're probably deploying, but then you're disconnected, right? It's not actively monitoring your Kubeflow clusters. It's not actively taking any actions if anything is going wrong on your Kubeflow clusters, right? And that's where operators shine, right? They have the operator lifecycle manager framework. The benefit which it brings is essentially giving you tools that, once you deploy Kubeflow through an operator, the job doesn't get finished after the deployment, right? It's essentially monitoring your Kubeflow deployment and taking actions if something has gone down, right? Trying to restart it, or you can configure things like send me an alert, right? So essentially managing the whole life cycle of it, right? And definitely going to the fact that you can then add more intelligence around updates and upgrades as part of it as well, right? And because of that, right, that one action also enabled the Open Data Hub team to actually do the great work they have done to make Kubeflow first-class citizen on OpenShift, but also standardize the deployment and management of Open Data Hub exactly in the same way as the Kubeflow operator, right? So which leverages under the covers customized KFDev combination, which we use into the Kubeflow community, right? So now you have a version where you can deploy both using exactly the same mechanisms, the same operators which are built on the same architecture of KFDev, and mix and match, right? And I'll start skipping some of the details about the components which are available in Open Data Hub. As I mentioned, the slides are there. There is opendatahub.io, the website where you can go and get more details around that, right? But typically, once you have them in OpenShift, right, you will see the deployment spread out like this, right? So for example, things which you probably don't see in Kubeflow ecosystem, like Kafka, provided by the strimzy operator or superset, or Airflow, they're all enabled by this as well, right? So superset, I mean, if you're probably working on the data science, you're probably familiar with it. It's hugely popular for data analysis and manipulation on top of relational DBs, as well as charting and graphing capabilities. Spark, I think we are all all familiar with, and majority of the users use Spark, right? So that's also enabled. There are two versions of Spark. One is a dedicated Spark operator, which enables to run Spark in dedicated mode, but there is also the serverless mode, which is based on the Spark on K8s operator, which is now also provided as part of the Kubeflow community. Airflow, I believe a lot of us do look at Airflow from an ETL perspective, right? And that's where Airflow has a lot of, I would say, specialization. So that's also available as part of the Open Data Hub install if you're interested in it, and by virtue of it available as an operator. Now Hive is something, right, which is very popular into the Hadoop ecosystem, right? It was a project which was initially started by Facebook to enable data analysts, right, to analyze the data in Hadoop, but in a more SQL friendly way, right? So that's where Hive has a strong ecosystem going. So if you do have data residing in Cassandra or Hadoop databases, right, you can leverage this to essentially run a lot of analysis and graphing and querying capabilities. So also available as part of the Open Data Hub architecture. Right, so I think what we said, Open Data Hub very strong on the data side. We have Kubeflow, which is very strong on the machine learning and AI side. You bring them together, and what you get is an end-to-end data machine learning and AI platform, right? So it's available, through Operator Hub, right? And if you need more details around how to get going this with, bringing both of these projects together in one single consistent way, please contact us. Go to opendatahub.io or reach out through Slack and others. Okay, so I think this is brings me to the end of my presentation at this particular point in time. Let me just see, probably have 15 minutes. So let me just do some quick demo. So I talk about the Kubeflow dashboard. By the way, is everyone's still seeing the screen, right? I shifted to a browser.
Yes, your screen is visible.
Okay, thanks. So this is, typical Kubeflow dashboard, as I mentioned, right? It gives you a view of the recent notebooks, or the pipelines you have launched, etc. You can launch into other things like metadata artifacts. So notebooks where, most of us start. So you can click on the notebook tab. You can launch a new notebook server, right? So you can specify the image based on which you are launching, specify or memory or CPU characteristics. So just take the defaults, right? If you don't want to be bothered by any of those, right? And you don't want to leverage a persistent volume, right? The fact is this is giving you more control. If you don't need more control, you want to just launch a default version, just check the defaults and you can launch it, right? And then you can also select, right, whether you want to run it on GPUs or CPUs, right? Once you have run it, right, you can then, when it is running, you can connect. And from here onwards, you are in a very familiar territory, right? You're probably familiar with this view, you use it, right? And then, from there onwards, you can launch Jupyter notebooks as usual and, go through this process, right? So for example, this is a notebook which is running on the Kubeflow notebook server. Probably wouldn't be running through this end-to-end, right? But this is one where we essentially use for showing, the KFServing capabilities, right? So in this case, right, we connect to a Kubeflow environment. Now I talked about, KFServing having multiple ways of entry, right? So you can either use a Python SDK, you can use kubectl, or you can use, KFP, Kubeflow Pipeline SDK, right? So this takes you through all these different ways. So in this case, the first one is, we are essentially using kubectl to deploy this scikit-learn model, a very simple model, 6 lines of YAML there, right? And then, you can use it to monitor. In this case, we see that it's still, deploying it. Okay, so now the model is deployed, then you can, move forward and launch, simple prediction. In this case, it comes back with a response. So the other aspect of it is that, as I mentioned with KFServing specifically, it's not only limited to kubectl, right? So if you want to work through a Python SDK, there is a Python SDK available as well, right? Which you can install and then use that, right, to serve your models, right? So in this case, this is a TensorFlow model which works on the TF-flower data set, right? The input is, simple flower data set if you want to get more details, but typically used in TensorFlow demonstrations, right, to show starting capabilities. But using that SDK, typically, then you are in the familiar Python world. You can import the different, capabilities you need as part of KFServing. And in this case, right, we are launching endpoint, right? And we are also launching Canary, so you can essentially, go through that. So this creates a service. So it has, in this case, if you see, it has deployed a model running on CPU. And then, it will watch. In fact, it's deploying the model, right? So this particular section will watch, once the model is deployed, then we can run inference. Now, I wouldn't go into, the more details of this particular demo. We will be going through this whole notebook end to end tomorrow, right? So if you're interested in model serving, right, this is something we will be doing much deeper dive tomorrow on that particular case, right? So with this, I will move to the next set, which I do want to highlight, is essentially the pipeline capabilities, right? So let's go back. Okay, so in this case, let's go back to our dashboard. Let's go to the pipelines. So this is one of the pipelines, right, which we created, right, which essentially, the use case in this case, let me see if I have any slides on that. Okay, probably not sure. So the use case in this case is, typically, this is a pipeline which trains a scikit-learn model. And then, deploys it on KFServing, launches some scoring clients, right? Now, this is based on a data set which is based on, refrigerator or the food containers, right? So typically the food and shipping industry, runs a lot of the food and shipping items which go to the store shelves, right? And when you actually get to them, you want to ensure that, the food items which are being deployed in super centers, right, they are good and they can be, placed in a consumable fashion, right? So that's where this demo is essentially deploying that model, which can tell us based on the different characteristics, if that particular container is good, right? So typically, if you look at the data set, so this is, by the way, Apache superset deployed as part of the Open Data Hub, right? So you have a very, strong SQL visual editor, right? So this is a typical database in that case, right? So you can run queries, it will fetch the database. So things like, the food containers, which are carrying your food items to the shelves, their, target temperature, ambient temperature throughout that life cycle, right? So it's constantly streaming that data, which is then going to a Kafka. And when we process that data using Spark, and then, put it in another channel on Kafka. And once that data is then, put on that, then this model is called to get the prediction from the model. Okay, based on these data which you are getting, right? Whether it's around the temperature or the carbon dioxide level or the oxygen level of these food containers, is the food good to ship or not? Right. Now, another thing which, Superset provides, for example, is, very strong capabilities, as I mentioned, around chartings and dashboards, right? So you can actually look at the distribution of the data, right? Where, whether it's the kilowatts or, the temperature distribution, the amount of time the door for a particular container might have been opened, the level of carbon dioxide, nitrogen, and oxygen into those. So a lot of strong capabilities, around charting and graphing provided as part of the superset, right? So you have your data in the SQL database, you have superset, you have analyzed the data, and then, you want to now have, machine learning model, which is trained on this data set and launched, right? So in this case, let me launch this particular one. So let me choose an experiment first. And I'm looking at, so there are other things which we specify as part of the input, right? Do we want to deploy a default and a Canary as well, right? So we are saying here, yes, deploy a Canary version of the model as well, right? And we want to say that, also this deployed model, will be using the streaming data for input predictions, right? So the streaming data will be coming on Kafka and on this particular topic, right? So as you get the data, please, call the model and keep on giving you predictions, right? So that's the essence of this particular pipeline. I will launch this pipeline, right? And hopefully, it goes through as it gets started. And while it is running, right, you can start looking at, the logs, etc., right? So in this case, this is going through the training process and training a model using Jupyter notebooks. And then, once the training is complete, the next steps, in terms of deploying it to KFServing, and others will continue, right? So hopefully, this is pretty, we are not, running any heavy duty training. So this should complete fairly quickly. And then, okay, the training has now completed. The notebook was uploaded. We are now deploying the model using Kubeflow serving. So that is going through process right now. We can trail along the logs in real-time fashion here, right? And it deploys the model, checks for it to be deployed, and then it does an inference check, right, very quickly. So all is so far looking good. And once it is deployed, it launched the post-processing scoring and monitoring clients, right? Now you can essentially, look at the inputs and the outputs section, right, where if you see, like, it gives you the specs around your Canary model, default model, right, and what were the output parameters where the model was deployed, what is the endpoint, etc., right? You can get all the details from here. Okay, so this now deployed the model and the clients which we need, right? The next step can be, okay, let's make sure, this is working in an end-to-end fashion, right? So as I mentioned, this deployed model will take the streaming data from coming in Kafka, right? So let me see. My Kafka UI is up. So this is a dashboard which we use for Kafka, right? So let me connect the two channels I have on Kafka and streaming mode. So this is the reefer telemetries where all the data will come based on the container's input temperature, etc. And then this is a Kafka channel which will check and tell me, if something requires maintenance, right? So we have the two Kafka channels running here, right? One of the other dashboards which we use is the Kiali dashboard, right, to actually monitor the traffic, right? You will see, it's a bit, shows all the models which are deployed, right? But so now, what one thing we can do is, launch some traffic on this, right? So here, I'm sending a request of around 600 containers. Let's say, they are carrying banana and there is some default data around those food containers, right? So if you now look at, the Kafka topic here, right? It's now, getting all these data coming from this, right? So initially when we connected, we didn't have any data, but it's still, streaming from that, and we can, send it once more to ensure that, it continues streaming data. And now as this is happening, right, one thing which is happening is, the model is getting called, right, on KFServing, right? So a little harder to see. Let me see if I can refresh and if it. But you can see, right, what KFServing is now trying to do at this particular point in time is, right, uh, uh, divert the model traffic, right, to default and Canary versions, right, in this case, and split it, in that uniform fashion, right. The Knative autoscaler obviously keeps on monitoring, right, and the monitoring aspects of Knative autoscaler are more, focused towards ensuring that, if there is scaling needed, right, it's scaling the pods behind the scenes as part of it. Just one more refresh. Okay, so I think this is, working as usual. And if you want to check, the other aspect of it, which is, do we get, like, if you look at the other Kafka topic on which we were listening, it has not shown any data where, whether a food container needs maintenance, right? So if you send a data, for example, this is a food container carrying apples, this is, the model now responds back, yes, it does need maintenance, right? So if it does need maintenance, then, you can have other capabilities integrated in, right? So that was one of the Kubeflow pipeline demos, right, which is being used more in the context of IoT and streaming data. The other, right, for example, which you can, I talked about, Kubeflow pipelines and Tecton integration, right? So just wanted to show something like, MNIST, right, which we typically use for showing the capabilities of Kubeflow. You can launch, and if you look at the YAML behind the scenes, right, for this particular pipeline, this is all Tecton, the Tecton pipeline run, pipeline spec, etc., which is bundled as part of it. And then you can launch a version of it. So exactly the same experience which we are used to with Kubeflow pipeline with the Argo backend we are running here, right? Now, this pipeline does take time, right? It essentially, runs training and it runs training over, quite a bit of, so let me see, if I have one which I have already run before. Yeah, so this one essentially, ran before and it went through the whole set of steps where essentially it's first, running hyperparameter search using Katib, right? So for example, in this case, let's see if we go to Katib, we might be able to see, uh, the current Katib experiment running. Oh yeah. So yeah, this one which I ran yesterday, this is which is currently running. So you can see that, it's currently running this, but the one which I ran yesterday, right, that one completed the hyperparameter search. And the goal of this hyperparameter search as part of that particular pipeline is to essentially, minimize the loss rate, right? And then, based on different combinations of the learning rate as well as the batch size. And if you see the result, it has probably come up with, this is the minimum loss rate at this particular with a batch size of 16, right? And the learning rate, I would say approximating to somewhere between 0.022 to 0.024, right? So, and then it launched multiple of trial runs and found the right hyperparameter, right, which is needed, right? Now, once you have those right set of hyperparameters, then essentially, it runs, the distributed training on top of these models, right? So in this case, this is using the underlying distributed TensorFlow operator, and then, deploys it using KFServing, right? And once the model is deployed, you can run typical inference. So I am at the end of the time, right? But hopefully, if you have time tomorrow, we will, in the Kubeflow pipeline and Tecton session, right, we can go much deeper dive into these pipeline aspects of it. One of the things which I do wanted to highlight was, right, for example, if you have run experiments, right, before, you can actually enable, the same, artifact tracking which you are used to, right? So for example, if you look at the logs, etc., you can, go to MLM metadata. In this case, let's look at the last one, the last phase, which is the model is deployed. So this one's, trained using Watson Studio, deployed using Watson machine learning, right? So if you see artifact tracking is enabled, if you use lineage tracking is enabled, you can trace the lineage. Okay, this is the model which is deployed. It was deployed using this component. This was the output, right? So, and then, this was the output of the storing the model on Watson machine learning. You can even go even back. Okay, and what was the output of the model, training the model using Watson machine learning, right? So all that lineage tracking and all this is enabled using, the Kubeflow pipeline with Tecton backend. So essentially you're getting the same first class treatment, right, which you are used to getting on top of Kubeflow pipelines with the current Argo capability. With that, I think, as I mentioned, we are at the end of the time. We can probably take questions for 5 minutes, but feel free. I mean, I'm always in the Kubeflow community on the Slack. Keep on pinging me with your questions if you do have questions after the fact.
That was awesome, Animesh. And the questions have been answered in the chat, so I think we're good, unless anyone else has questions. And we're going to take a 15-minute break, is that correct?
Yes, I believe I definitely need one. So yeah.
Yes. So a 15-minute break, and then we start on the hour.
Yeah, and I think the next two sessions to highlight would be, if you are interested in setting up a development environment specific to Kubeflow, as well as understanding the Kubeflow control plane to deploy Kubeflow, they're pretty important from that perspective. And, Wei Shang, who is known by the name Adrian into the Kubeflow community, right? He will be leading them. He, spends his day working on the Kubeflow control plane, with the rest of the members in the Kubeflow community. And then, there will be a workshop as well, right, for folks to actually go through and hopefully, get a successful Kubeflow deployment going. So let's take a break and then sync up at the top of the hour, right?
Great. Okay. Thank you, Animesh. Thank you, everyone.